Hello again. Today we are going to discuss deformation. Deformation is very important in animation. Can you tell how fast is the Roadrunner going? Of course. Deformation can tell you a lot of things about direction, speed, forces acting on our objects. We can clearly tell how fast he's going. And here, deformation shows you the forces acting on our object. Even objects as hard as a golf ball can really stretch, squeeze and deform. And animation is an art of exaggeration. Deformation can help us to achieve stylized, interesting and very dramatic movement, like here in a film called Pivot. So let's see how the different stages of deformation influence the perception of animation. Here we have our bouncing ball. It's a regular bouncing ball, nothing special about it. But the other one has something added to it. It squeezes on the bottom, and the movement should already feel much more dynamic. The movement is almost exactly the same with added deformation. And the third one is also doing some stretching. Now you can compare and see the difference, and I think you'll agree that the third one is the best. Maybe it's not the most physically accurate, but it's the most interesting. So the deformation is a very important tool. But speaking about bouncing balls, do you remember what we did last time? Yeah, we did a bouncing ball animation. So before we dive in fully into deformation, let's try to perfect our bouncing ball animation skills. You will see me drawing a motion sketch here, but the movement won't be only vertical, it will also move in a horizontal axis. So the movement will be a little bit more complex, and as you can already see by looking at the motion sketch, we will have some dampening of the force, and we will lose some height. Every time the ball bounces, it loses some momentum. Now I'll add stages to the motion sketch, and I will make those distances larger when the ball is falling down and smaller when the ball is moving up. And now let's try together animate this bouncing ball. One more thing that you can notice me doing here is that I'm trying to rotate the ball because it's not completely round. So I'm trying to rotate it in such a way that it's always pointing in the direction of its movement. I hope you did well and you're satisfied with your work. Alright, back to deformation. Look at this foamy ball or this balloon. Can you tell what's interesting about them? It's the most important rule when it comes to deformation of objects. It's a rule of constant volume. It means that the size of the object doesn't change. When you squeeze an object, it will stretch the other way or the other axis. It's a very important rule that you should always follow when using deformation. But how to actually do deformation? It's simple when you use techniques like drawing or 2D or 3D computer animation. But when it comes to real life objects, it's a bit more difficult. Why? Some of the objects can bend, but it's hard to bend them back or they become easy to break, and some objects just break. And most of them you can't really deform. So what options do we have? It's time for an experiment. What I have here, it's a box of rocks I've collected during my holidays, and I'll choose rocks with different shapes but similar colors, and I will use them as the different stages of the deformation of our bouncing ball, because that is what we're going to animate next. We will animate our bouncing ball, but with deformation. You don't need to use rocks or stones, you could use vegetables or fruit, whatever you can find, which has different shapes and sizes, but similar colors. So let's try to draw a motion sketch for that. We already know how the ball should move, which distances should we use, but with shapes, deformation is caused by two things: forces acting on our object, like hitting other objects, and the speed itself. When the object moves very, very fast, it can stretch. We should show the speed and also all the impacts. So we have only one impact with the ground, and the rest it's caused by the speed. So we will add some stretching in the middle, and we will add some squeezing when the ball touches the ground. Alright, let's try. As before, we'll start slowly by moving little, then we will make those distances a bit bigger, and when they're becoming bigger, it means we have more speed, so we can change the shape to the one that it's a bit more stretched. And as before, we're trying to get back to the same position that we started with. Alright, that's it. Doesn't look better than before? I think it's much more interesting. What else can you do? Look, I found some spoons in my house. They are similar color and different shapes. What could I try to do with them? If I just change their shape without changing their positions, I just need to put another spoon in the same spot, and the result of that should be also quite interesting. Take a look, we have a beating heart. It's not always about the shape, sometimes it's also about the rhythm. That's the first approach. Use similar objects. What's the other method? You can use more objects. Your shape can change a lot if you add more objects to it and make your scene more complex. It's a bit harder to animate because you need to control more objects, but you have much more possibilities. Look, by just moving some spoons around, I can animate a peacock. If you use more tableware, you can even have a living, breathing and walking peacock. Alright, third method. The third method is just a method of using objects that can bend, squeeze, or stretch. So, deformable objects, like this ball that I've made. I can form it in almost every shape I want, so it can be round in the beginning. I can stretch it out. You know what it is? Actually, it's one of my socks just filled with rice. So now we should put our knowledge into practice. Let's animate last bouncing ball, but let's animate more complex movement, and let's also add deformation to it. So we should already know how to change positions, so we're moving more on our way down and moving less on our way up. But let's also add deformation to it. While moving fast, we stretch the object out, and while slowing down or decelerating, we're going back to this regular starting shape of our object. And that's it. I hope you're convinced, and I hope you will play around with deformation. I would like you to try different methods of deformation on your own. Try to repeat the steps I mentioned. Have fun and good luck.